Bismillahirrahmanirrahim. Okay, I'm going to elaborate on these concepts. Okay, so exponential functions, okay, are useful in everyday life. Just yesterday or the day before, I looked at half-life of a certain medication. It was 12 hours. That's an exponential function. So in my mind, I had to calculate how many half-life it would take for me to be safe to do a procedure on a patient. So these are everyday, common, useful things. Okay. So the first real-life example we gave about exponential function was about compound interest. Everybody should know the formula for this one. What's this? Right? Wrong! What kind of compound interest formula is that? I just wrote something junky. No, that's not it. What? Oh my God, you guys see what I mean? No, it's 1 plus R over N. My goodness. R over N to the power of N times T. Now, what's the independent variable in this equation? T. Time. That's like the X, okay? Time is the independent variable T. So this is a compound interest formula. Okay, there are different simple interest, compound interest, and then there's continuous interest, etc. Okay, so this is a compound interest formula. In other words, the interest is being calculated at given interval of time. Okay, so P in this compound interest formula is the principal amount. In other words, see, bank want your money, right? So the bank wants you to give them their money. Bank want you to give them your money so you can put it in the bank. The bank take the money, they invest it somewhere else, they make money out of your money. To give you an incentive to put the money in the bank, they say, okay, if you put the money in the bank, we'll give you some extra money when you need it. Right? We'll give you money back in interest. Do you follow? So they give you interest money back, right? So, but the amount a person puts initially in the bank, that's called the principal amount, right? So if somebody goes deposit $1,000 in the bank, that's P. That's the principal amount. That's the initial amount of value. Okay? The interest that's given, like 3%, is what, say, 3% of the value. Okay? N in this equation over here, okay, that's how often interest is calculated. Do you understand? How often interest is calculated. Okay? Now, if a bank, let's say, we're going to give you 3% interest and we calculate the interest every 6 months. In other words, when 6 months comes, they calculate the interest and add that to your value. And then after 6 months again, they do the same thing and put more money in your account. So if there was another bank that says, it's okay, we give you 3% interest too, but we will calculate it every quarterly, 4 times a year instead of every 6 months. Why? Because they want the customers to go over there. Do you understand? The more frequently the interest is calculated, the more money the person gets. Does that make sense? Okay? So N is the number of times a year, how often interest is calculated. It's the only variable that's twice in this equation. It's over here and it's over here. See? So if interest is calculated yearly, N is 1. If the interest is calculated every 6 months, the N is 2. Quarterly, N is 4. Monthly, N is 12. So N is the how often interest is calculated. Okay? T is time. Okay? So, and then A is a dependent variable, is the amount of money in the bank after a certain time. After a certain time T. So in other words, here's a real life example. Let's say if somebody puts $2,000 in the bank, okay? So they put $2,000 in the bank, and the bank is generous, and the bank gives them interest of 3%, calculated 4 times a year, quarterly, and is 4. Okay, how much money will this person have after 5 years in the bank. Okay? To do that, you say, okay, A equals the principal amount, which is 2,000. Okay? 1 plus a rate, 3% is 0.03. Okay, 3%. Another way of writing 3% is 3 over 100, which is 0.03. You don't write 3% here, okay? It'd be haram to do this like 3 over 4 or something like that. That's just like, okay, it's 0.03. That's what 3% means. Over 4 to the power of 4 times 5. T is 5. Does that make sense? Okay. So 2,000. Okay, what's this divided by 4? What's 0.03? Is 0.0075, right? Correct? 220. Right? Somebody better check on me. That's 2,000. You can simplify this 1.0075 to the exponent 20. Correct? So somebody do the math over here. What do we get?
It's like 2,322.4.
2,322? Like this?
Yeah.
0.40. So that's how much money they have after 5 years. They made $322.40 just putting the money in the bank for 5 years. Do you understand? Okay? Do you understand? So this is a very specific example. A specific example. Now if you look at this function, okay, just look at this over here. Okay? I'm going to write this 4t. Look at this over here, okay? See this? This is an exponential function. Let me write this over here. This is an exponential function. It's like y equals b times a to the x, like that. So it's, if you were to graph this, the person's money is going to grow. Y-intercept is going to be 2,000. It's going to grow exponentially like this. Now this function is not going to go over there because you can't travel back in time. Do you understand? Does that make sense? The domain is restricted. Does that make sense? This is exponential growth. Fahmed? Okay. So compound interest is an example of an exponential function. And if you look at this, a over here, a is greater than 1. If it's greater than 1, the growth is exponential. The model of this, the parent equation, is y equals 2 to the x. Does that make sense? Yeah? Does that make sense to everybody? Come on. You get it?
Yeah.
Okay. Alright? Now, watch. Person takes certain amount of medicine, okay? Ibuprofen, I forget the exact values, okay? They take, let's say, 200 milligrams of ibuprofen, okay? The medicine, and this is the initial value of of how much it is. The medicine decays in the blood. I don't know exactly how fast it decays. Okay, let's say it decays at a rate of 75% every hour. Okay. Well, this is not good. There's an example in your book. Can I see your book? Let's do the one in your book. Okay. Okay. Bismillah. So now this example, this is a very specific application of exponential growth. Okay, of exponential function. This is only true for compounding. You can't use this for, like, bacteria in a petri dish, because they don't calculate themselves every certain. This is a formula for compound interest, but bacteria in a petri dish is a different story. That's also exponential growth. But any exponential function that will be modeled by something like this. Okay. Now this is an exponential growth model. Okay? and this is exponential decay model. Now look at this. The only difference between these two formulas is a plus and a minus. Okay? So, yes. The B will be the principal, the original amount of something. Now your book uses A instead of B, but I like to use B for sake of consistency. It makes more intellectual sense to me to do that. So B, okay? The original amount. So bacteria in a petri dish, you would use this formula because that's exponential growth. And R would be the rate of growth of the bacteria. You understand? Now, now this over here, exponential decay. So if you have for example, you bought a car for a certain value, and the value of the car depreciates by a certain amount every year, you would use that exponential decay model. The rate would be subtracted. In this case, the rate would be added. Does that make sense? Okay, so let me give you an example of this one I gave, because I remember that one. So let's say you bought a car for $25,000, okay? And the value of the car goes down by 12% every year. Do you understand? How much will the car be worth after 10 years? Okay? This is an exponential decay. So the formula would be something like this. Okay? The initial value of the car was 25,000, and the rate of decay is 0.12 t. So this is 25,000 times 0.88 t. So this is the equation for the value of the car every year. You can use this for 10, 5, 20, whatever years. Okay, so we're given 10 years. Let's calculate this for 10 years. So somebody do the calculation for me over here. Okay, what do we got? Who? Not a lot, huh? So look how much the value of the car assuming that that's the depreciation value, which you understand is probably accurate. Does that make sense? So, how do I graph this? Well, what's the y-intercept? It's that, right? Let's do it right here. I'll show it to you. So if you want to graph this, it would be y equals 2500. This one here. 2,500 times the quantity 0.88. No. 0.88 to the exponent of what? Nothing happened, right? We have to zoom out. The y-intercept is 2,500. Alright. Oh, there it is, see? It's the exponential decay model. Do you understand? Okay. So this is an example. So, and I'll summarize this and then also take a break. So, any exponential growth can be modeled like this. And any exponential decay can be modeled like this. This is exponential decay. Okay, exponential growth. Now, there's another formula which I'm going to mention. Okay, this is a specific formula for like stuff that decays that has a half-life. It's a half-life. Okay, the formula for half-life is slightly different. You put to divide t by the half-life. Okay, you put an h there for half-life. Okay, so if this has half-life, okay, I explained this in one of the videos for Algebra 2 classes, why the formula is different, okay, but we don't have time to explain this for half-life. But let me explain to you what the concept of half-life is, okay? Half-life is the amount of time it takes for half of the substance to decay. Okay, so imagine you're starting off with this much amount of stuff. Okay? If the half-life is, let's say, different books use different things, so you propose h. So half-life, let's say, is 50 hours. After 50 hours, half of the stuff will remain. In the first half-life, half of this will remain. After another 50 hours, half of that will remain. After another 50 hours, half of that will remain. Like this. So you can see how this is kind of like exponential decay model like this. Does that make sense? So what happens is, for example, xy, if the original amount is, let's say, 300, okay, this is initially. After one half-life, it would be 150. After two half-life, it would be 75. After three half-life, it would be 37.5, like that. Do you understand? Half of the remaining amount. Does that make sense? The half-life formula for stuff is slightly different. It's like this. The half-life. H goes over here. Okay? That's slightly different. And that's that. So after a brief pause, we'll come up with the plan for the rest of the morning, inshallah. So let's listen on.